All right. Hi everyone. So today we're going to talk about the IELTS composition marker. My name is Ziqing.
I'm Chang.
So for those of you who never see this logo before, it is the abbreviation for International English Language Testing System. And so it is required by all international students, that's just like me, to get into any universities in UK, Canada, and US. And personally, I took this 5 times back in 2016. And each test cost me like $400, and you had to wait 2 weeks to get a result. So it was a truly painful process. And the test has 4 parts, which are reading, writing, listening, and speaking. And personally, I find the writing section most difficult because there is never a general solution for essay and how subjective the writing tasks are. So our model would take 2 inputs. The first input would be the question by itself, that is around 25 words. And as you can see to the right, there's a sample for it. And the second input would be the answer that is written by the student, that is around 250 words. And we're just trying to predict a single output of 1 to 9. So for the data collection process, our data collection was pretty straightforward. And since there's no existing data set, we have to do everything by ourselves. So the first data collection process was actually done completely by hand, which we just copy and paste everything into a Google Excel sheet. And by doing that, we gathered around 200 data entries. And that process was actually pretty boring and repetitive. And then we used a Python scraper to collect the remaining 3,800 data entries. So after we collect all the data, we had to do some post-processing for our data set. What we did was to remove some of the overpopulated labels to ensure a balanced distribution among all the labels. So which means there are just too many good essays out there on the internet and so little bad ones. People just don't post them. So we want our model to be a good and bad essay predictor instead of just good ones. So here is our class labels. As you can see, we're just categorizing everything under 4 into label 0. The first reason is that there are just so little amount of examples that is less than 4. And the second reason is that we believe that everything under 4 is pretty much the same. And we're just categorizing everything else apart from 0.5 to each other all the way up to 9, so result in a total label of 12. So this is our baseline model. Our baseline model has a CNN architecture, which has 2 separate CNNs. The first one takes the model. The first one takes a topic, and the second one takes the content. Followed by that is a convolutional layer, which produces the feature map, and then a maximum layer for just extracting all the features. And we just concatenated them into a fully connected network, and it has the output of 12. So we are using a cross-entropy loss for our baseline because it's pretty much standard for a classification problem.
Okay, for our model architecture, it's a GPT-2 fine-tuned model. And the input is the combination of the topic and the content. And the tokenized input will be passed through the GPT-2 encoder to output the representation. And finally, the representation are passed to a classification or regression head. And finally, the entire model will return the prediction that's between 0 and 11. So why do we experiment with 2 different heads? So for classification head, it's pretty straightforward. It's a fully connected layer that takes in the representation and outputs 12-dimensional vector. And this 12-dimensional vector will be passed into a softmax and cross-entropy loss. However, we wanted to update our model parameters more if the model predictions way off the label. So we wanted to experiment with something like L1 loss or MST loss. That's why we needed to see what the regression head would do. So the regression head is basically a fully connected layer that outputs a single scalar, and the scalar will be passed through a customized piecewise function that bounds the range of the scalar into between 0 and 9. And finally, it would do an MSE loss with the label band, a score band. So some quantitative analysis on the validation set. For both classification head and regression head, the GPT-2 fine-tuned model does much better than the baseline model. And for the regression head, the GPT-2 fine-tuned model actually has a lower average distance. So we have 2 different metrics here. One is the exact matching accuracy, and the other one is basically the difference between the prediction score band and the label score band. And for the regression head, it has a smaller average distance, and for the classification head, it has a higher exact matching accuracy. So here we selected 2 examples from online outside of our data set that are also representative. So one example will be a bad essay and the other one is a good essay. So this is the bad example. As you can see, this is a pretty badly written essay. It has lots of grammatical errors and also doesn't have lots of rich discussion around the topics. And our model would produce output that is less than 4 as a final prediction. And for this example, it's a clearly much better written essay. It has more context around the topics, and it also has much less grammatical errors. And as a prediction, our model says a 6.5 score essay, which is a pretty good score for IELTS composition if you have studied about it. And finally, we do see a performance increase in GPT-2 fine-tuned model as expected compared with the baseline. And we would expect further improvement in the performance if we fine-tune on the GPT-3 model. And finally, if we're going to do this project all over again, we probably spend more time on the data collection part because the initial iteration is we only collected 200 samples, which resulted in much worse performance than what we have right now. Thank you.